So we'll be doing homework number 3, problem 32. So 2 point charges are 2.0 centimeters apart that have an electric potential energy of negative 180 microjoules. The total charge is 30 nanocoulombs. What are the two charges? So let's let the two charges equal Q1 and Q2. So we know the total charge is 30 nanocoulombs, so that's the total charge would be Q1 plus Q2 added up together. So Q1 plus Q2 equals 30 nanocoulombs. And let's convert it to coulombs now because we're going to have to use it in coulomb units later on. So to convert it, so it's 1 coulomb per 10 to the 9th nanocoulombs. So that will equal 30 times 10 to the negative 9th coulombs. So we also know that the electric potential energy is negative 180 microjoules. So that's U equals negative 180 microjoules. And let's convert that to joules. So it will be 1 joule per 10 to the 6th microjoules. So that will be negative 180 times 10 to negative 6 joules. And we also know that the 2 point charges are 2.0 centimeters apart. So let's have that as R, 1 to 2, and that is 2.0 centimeters. And let's convert that to meters. So 1 meter has 100 centimeters. So that's 2.0 times 10 to negative 2nd meters. All right, so we have one formula, Q1 plus Q2. So we need to have another formula, and because we have all the units, we have these units available, U and R12. So let's use a formula for an electric potential of 2 point charges. And we can plug in these units in and solve for Q1 and Q2. So the formula is U equals 4 pi and Q1 times Q2 over R12. So plugging everything in, we know that this equals 9.0 times 10 to the 9th Newton times meter squared divided by coulomb squared. And then we don't know Q1 or Q2. And R12 equals 2.0 times 10 to negative 2 meters. And U equals negative 180 times 10 to negative 6 joules. So now let's cancel out the units. So meter can cancel out one of the meters. So Newton times meter, that also equals joule. So the joule and Newton per meters, that cancels out. So we're left with coulomb squared. So let's solve for Q1 times Q2 by multiplying 2.0 over, 2.0 times 10 to the negative 2nd over, and dividing by 9.0 times 10 to the 9th. So Q1 times Q2 equals negative 180 times 10 to the negative 6 divided by 9.0 times 10 to the 9th coulomb. It's a negative 2 because it's in the denominator. And then multiply by 2.0 times 10 to the negative 2nd. So that ends up to be negative 4.0 times 10 to the negative 16 coulomb squared. So now we have two formulas, Q1 times Q2 and Q1 plus Q2. So let me write it out down here. Q1 plus Q2 equals 30 times 10 to the negative 9 coulomb. And Q1 times Q2 equals negative 4.0 times 10 to the negative 16. So let's solve for either Q1 or Q2 in this equation and then plug it in to the multiplication question over here. So let's solve for, or let's isolate Q2. So you subtract Q1 on both sides. So Q2 equals 30 times 10 to the negative 9 coulombs minus Q1. So let's plug in this Q2 into this formula. So it will become Q1 times 30 times 10 to the negative 9 coulomb minus Q1. And that equals to negative 4.0 times 10 to the negative 16 coulomb squared. Okay. Now let's multiply this out, the Q1 to this and Q1 to that. So that will equal 30 times 10 to the negative 9 coulombs, Q1 minus Q1 squared. And let's add the negative 4.0 times 10 to the negative 16 coulomb squared over to this side as well to have 0 at the end. That will equal plus 4.0 times 10 to the negative 16 coulomb squared equals 0. So let's divide both sides by -1 so we can get the Q1 squared to be positive. So we'll end up with Q1 squared minus 30 times 10 to the negative 9 coulombs times Q1 minus 4.0 times 10 to the negative 16 coulomb squared, and this is still 0. So we can factor this out. We can factor out this polynomial, and we'll end up with Q1 minus 40 times 10 to the negative 9th coulomb times Q1 plus 1.0 times 10 to negative 8 coulomb equals 0. So Q1 would equal, when we set it to 0, will be 40 times 10 to the negative 9 coulombs. Q1 also equals, when you set this to 0, it will be subtract 1.0 times 10 to the negative 8, we'll be left with negative 1.0 times 10 to the negative 8 coulombs. And let's set this both to, let's both convert them to nanocoulombs so it's a little easier to read. So this would equal positive 40 nanocoulombs because the conversion is 1 coulomb for 10 to the 9th nanocoulombs. I'm not going to write it out, but that's conversion. The conversion is the same as above here. So negative 1.0 times negative 8, if you multiply that by 10 to the 9th, you'll be left with negative 10 nanocoulombs. So we have two solutions for Q1 now, plus 40 and negative 10. So let's solve Q2 for both of these. So for Q1 equals plus 40 nanocoulombs, let's plug it into the original equation, Q1 plus Q2 equals 30 times 10 to negative 9c, or, sorry, Q1 plus Q2 equals 30 to the nanocoulombs. So I'll write it out here. Q1 plus Q2 equals 30 nanocoulombs. So we'll have 40 nanocoulombs for Q1 plus Q2 equals 30 nanocoulombs. Subtract 40 over, and we'll be left with negative 10 nanocoulombs. Now, so that's for the plus 40 nanocoulombs. Let's do it for Q1 equals negative 10. So for Q1 equals negative 10 nanocoulombs. So same formula. So let's plug in negative 10 for Q1. And then solve for Q2, and we'll be left with 40 nanocoulombs. So we see that we're both left with plus 40 and negative 10 for both situations. And we're looking for two charges. So our final answer is the two charges are negative 10 nanocoulombs and positive 40 nanocoulombs.